I'm John Killian.
And I'm David Altenhofen, and today we're going to talk to you about transistors. We're going to show a circuit for where we're measuring current to test our gains through the transistor, and then we're also going to have a little surprise with the DAC later on in the video, so stay tuned for that. So here's John to start us out.
First I'll explain what a resistor is. A resistor in a circuit looks like this. You have your base B, your collector C, and your emitter E. The base controls this big flow of current through here. It could be something like 2 amps, but this 2 amps is controlled by just this tiny bit of current that from here. This could be like 2 milliamps. This 2 milliamps is controlling all the 2 amps that is flowing through here. Now, the step up from the 2 milliamps to the 2 amps is what is called the gain. It's comparative to the Mississippi River flowing through here being controlled by the tiny little Kinnickinnic. The greater the flow of the Kinnickinnic River, the greater the flow of the Mississippi River. Now all DMMs have a place to put a transistor in them, so you just put your transistor in, turn the knob to the transistor setting, and read what number it gives you. This gain is 143 for the current transistor. So the specifications when looked up on the internet were that the gain should be somewhere between 40 and 300, and our gain of 143 seems. One possible use for a transistor would be in a motor controller, and I just so happen to have to build one for my robotics club, and this right here is an Arduino microcontroller, and it can only take a few milliamps, while this motor requires like I think it was 0.5 amps or something like that. So this can't get enough power just from this, but I still want to use this to control the motor, and that's where a transistor comes in. I would put a transistor in here with the base going to the Arduino microcontroller, the collector going to my external battery source, which is just this 12-volt battery here, and then the emitter to the motor. Sorry, that's a very poorly drawn transistor, but you get the gist. Now you see this 12-volt battery hooks up to here, the base goes into the microcontroller, B, C, and E. And that is one way to use a transistor in a very meaningful and useful way. Now this is really cool. From the last lab that we did, we know we calculated the voltage versus current, and I noticed that we could use this to calculate the gain of a transistor. And it's kind of complicated and necessary since we have the DMM, but it's a fun, simple thing to do to have fun and use more lab stuff. So, as you can see, the overall program looks pretty much the same. I haven't even renamed it from lab number 2. Really, the only difference is that instead of running between -5 volts and +5 volts, is that we're running between 0 volts and 6 volts. To only read the current, we have to divide by the resistance, and so we did that here. The resistance is actually 1K, but to get our numbers more easily visible, we divided by 0.1, so the graph you can see easier. But then when we were making the graph, it's pretty much exactly the same once again. This is where it's kind of different. The slope before was the resistance, I believe. This time the slope is the gain, because the emitter Y and the base X, the slope of a line is rise over run, so Y over X, emitter over base, will give us our gain. Now let's watch this run through a few times. Let's see, run program. It's cycling through the voltage, and it found the gain to be 128.137, which is pretty accurate. Now let's run it through one more time just to see how accurate we are. And 127.8. That's very, very good. the gain was within 1. Say that makes sense. And that's all we did to reconfigure our LabVIEW program from lab number 2 to our transistor lab. And here's David with the rest.
Hey, this is David, and we're going to talk about setting up our circuit for testing the currents going through our transistor, through the base, and through the emitter. So this is our circuit. We have a power supply connected to the base and to the collector end. We have a resistor in series with the emitter end of the transistor. The current going through the emitter will be multiplied about 150 times the value of the current going through the base. To test the current in our circuit setup, we inserted a multimeter in series with the base current to measure our current across the base of the transistor. We also inserted a digital multimeter into the emitter branch to measure the amount of current going through that branch, as well as inserted a resistor to prevent our circuit from overloading. After we turned on our power supplies for our circuits, the digital multimeters read out the current values across our base and emitter for our transistor. These values represent approximately 160 gain from the base current to the emitter current. After we got our first values recorded, we adjusted the voltage output on the power supply for base voltage first, and the emitter current changed proportionally to the current change through the base, and afterwards we changed our voltage supply through the controller, causing the voltage through the emitter to change, resulting in a change in our base current. Here's our DAC setup for measuring voltages across our transistor. We calculate the current going through our base and our emitter. We connected our analog out cables from the DAC to the base part of our transistor to act as a power supply for it, and had a logic program to vary the voltage going through the base, which results in a changing current. We had to add a second resistor to our base leg of our transistor. We used the first analog input to measure the voltage drop across this resistor and use this to calculate the current going through this resistor. We connected our second set of analog input to our other resistor in the emitter leg of the transistor to measure the voltage across it to calculate the current going through that leg. This was all the setup that was required for setting up the DAC to calculate the current through the base and emitter of the transistor. We were largely able to use our previous program created for the last lab. This was all the setup that was required for our circuit for testing our transistor.
I hope you enjoyed, and we'll see you next week.